Okay, thank you. Good afternoon, everyone. This is Rani, and this is Karina. And today we will together present our study about a blockchain-based approach for embodied carbon management along the construction supply chain. Yeah, and for the first two parts, I will present, and next, Karina will continue with the presentation about system design, development, and our summary. Yeah, and first let's take a quick look at the research background in our study. According to the latest report published by the United Nations Environmental Programs, the global building sector was a major energy consumer, and it accounts for 34% of the final energy demand, and also at the same time, the carbon dioxide emissions from building operations and construction makes up 37% of total global carbon emissions. And when we take a detailed look at the different parts of embodied carbon, we can see that the whole embodied carbon can be divided into several parts, including the whole life cycle carbon can be divided into several parts, including embodied carbon, operational carbon, and some carbon beyond the life cycle. And for the embodied carbon, it consists of the upfront embodied carbon and the use stage embodied carbon and some part of end-of-life embodied carbon. And our focus will on upfront embodied carbon, which are the emissions caused in the materials production and the construction phases of the life cycle before the building or infrastructure begins to be used. And the reason why we focus on upfront embodied carbon is that according to the percentages, we can find that the upfront embodied carbon account for around 30% of construction projects' whole life cycle carbon emissions. And this percentage is increasing because of the decrease of operational carbon. So it's actually important to manage it and reduce upfront embodied carbon from construction supply chains. And however, we found some problems exist in the existing practices on upfront carbon management. For the example, the first problem is that due to the massive carbon emission data required for assessment and tracking, the current carbon assessment and tracking is data intensive. And also because of the fragmentation of construction supply chains, it is actually hard to gather consistent and accurate data on carbon emissions from each stage of the supply chain. And finally, because of there is an increasing disclosure requirements for Scope 3 carbon data, however, the current data transparency is limited both for the internal carbon management and external supervision, which cannot meet the disclosure requirements for embodied carbon in Scope 3. So in that case, with the advances of technologies, we found that blockchain can provide us a powerful and promising tool for the existing upfront embodied carbon. And blockchain is a decentralized distributed database system which records the data transactions, and the information records in blockchain, they are secured by cryptographic algorithm and also consensus mechanism. And we also know that several key technical properties which have been already introduced by previous presenters, such as data immutability, transparency, and traceability. And also there are several applications that about blockchain-based applications in different fields, such as financial services, supply chain management, and healthcare data management. However, we also found there are several challenges for data-related adoption in blockchain-based applications. For example, the data privacy concerns of sensitivity information due to public blockchain, and also the data quality concerns before uploading to blockchain. So in that case, in our study, we finalize our research questions. The first one is that how can blockchain technology integrate with carbon management along the whole construction supply chain? And the second is how can carbon data quality and privacy be enhanced in the blockchain-based carbon management system? And so comes to our research objective, which is to propose a blockchain-based approach for transparent and trackable carbon management along the construction supply chain for all stakeholders. And here comes our methodology, which is based on the research design method. And first, we will identify the problems and define the objectives based on the literature review and industry interviews. And then we will design and develop the system demonstration with several construction scenarios and cases. And finally, goes to the evaluation and communication. And here we listed several interview questions during the industry interview. And next, Karina will continue with the introduction about the interview results and our detailed problems. Thanks.
Hello. And because we have interviewed around 11 stakeholders in the construction industry, including suppliers, contractors, consultants, architects, and developers. Based on the result, we have identified the existing practice and problems of carbon tracking in the construction industry. I have further divided in the construction supply chain into two groups: parties within a project, public such as financial institutions. Under the normal case, contractor requires the information from the suppliers and then gather together to input to the existing carbon assessment tools to have the project carbon emissions. However, there is a concern on data tampering because of single points of input. Also, instead of single suppliers, we have hundreds of products and suppliers in a construction project, which result in data transparency concern. Usually the data, the carbon emissions data can share within a project, but not for public because of confidential information, which result in less transparency and privacy concern. Our system is to enhance the information sharing in terms of data quality, transparency, traceability, and privacy preservation. Okay, what is the system framework? In our blockchain-based carbon management system, the architect is responsible for the project, creating the project account and then adding the stakeholder into the project account. Supplier and the contractor is responsible for carbon emissions data input, while the developer and consultant is taking the role of carbon monitoring and data verifications. The first technical highlight is called role-based asset control functionality, which means each stakeholder has a clear role and functionality in the system. For example, only those input parties and validation party can view all the data in the system, while architects, which is not in the list, can only view the total carbon input data. And all our detailed carbon informations are stored in the off-chain traditional information management system, including the product emissions data, upfront transportation data, site activity data. Also, we considered BIM material take-off applications for the input of material specifications and quantity to enhance the input data quality. The second technical highlight is called hierarchical hashing strategy for validation, which means we are hashing the detailed data as first hash. The second hash is, or the remaining hash is for the validation process data. I will talk about more detail in the later slide. The third technical highlight is selective data disclosure before on-chain, which means the party or the responsible party can select those data to be encrypted before uploading those data to the blockchain. Okay, the output data are the information to be uploaded to the chain, including the project emissions data, company emissions data, as well as the hash value of validation process data. Once it's uploaded to the public blockchain, you can share to the public as well as the project team. Okay, I will further elaborate how does the system work in a supply chain level. First, the architect create or add the project and project team information, create the first block. Second, the supplier adding the product and transportation information, creating the second block. The quantity to the third block. If the supplier has the have the privacy concern, he can encrypt the sensitive information before acting to the next spot. Contractor acting further information about activities, site activities, emissions data, consumption. Developer finally acting the total project emissions data. Because of linked unique hash value of the blockchain features, it can enhance the traceability and data quality. Once the information is uploaded to the blockchain, it's open access to public and project team, so to enhance the transparency. I tried to figure out an example for better understanding. Architects first create an account A, add the developer A, contractor A, supplier A to the account. Supplier adding the concrete emission factor, the transportation emission factor distance to the system, and then as well as the quantity of concrete. Contractor further adding the electricity emission factor and its consumptions. Developer finally uploading the total project emissions. We can track how the total project emissions come from, such as when and who input those data. And for the system development, I will share some screen capture of prototype. Those screen capture showing the user interface of product emissions data input, as well as the product quantity input. This slide is the user interface of summary for the hierarchical hash strategy for validation that I mentioned before. Those cloud is the first row, is all the data we will going to generate a first hash. After the data are validated by the first party, the supplier, we will generate the second hash. For the remaining hash is from the contractor and consultants. This is what happened when they uploaded to the blockchain, what happened to the data when they upload to the blockchain. You can see the first two line is the data hash value, and then we can find the, for example, the emission factor, such as from HKE, and then the overall flow of the data will upload to the chain. And to summarize, our objective is to propose a blockchain-based approach for transparent and traceable carbon management along the construction supply chain for all stakeholders. In our system, we consider an off-chain traditional carbon management method and on-chain public blockchain for the storage. We have 3 technical highlights, including role-based access control for functionality, hierarchical hashing strategy for validations, and selective data disclosure before on-chain. The expected contributions of this research is to enhance the quality and traceability of embodied carbon data for more accurate carbon assessment by using blockchain during the construction supply chain management. And that's all for our presentation. Here is the acknowledgement as well as key reference. And I will pass to Rainy to talk about our upcoming event in Hong Kong.
Yes, thank you.